Yes, I'm serious. I'm going to show you guys how to integrate the cube root of tangent x. I'm going to show you guys all the steps, and hopefully everything can fit on this whiteboard here, right? So here we go. We are going to start with a u substitution. We'll say that u equal to the cube root of tangent x. And in fact, you could have started with a different u substitution, but that way it's not that obvious. Let me just show you guys this right here, and I'll tell you guys what the other way is though. This is more obvious, this is more direct, I would say. Anyway, let's go ahead and cube both sides. So we have u cubed is equal to tangent x, and then differentiate both sides. So we have 3u squared du equal to the derivative of tangent x, which is secant square x dx. And just like when we're integrating the square root of tangent x, we have to look at this right here and square both sides, because the secant square x, it's not invited in the u world, right? So square this, square that, we know that tangent square x will be u cubed square is going to be u to the 6 powers. You multiply the powers, so this is u to the 6 power. And you know this right here is secant square x minus 1 equals to u to the 6 power. And then we can just add 1 on both sides. So in other words, secant square x is equal to u to the 6 power plus 1, right? And now, to isolate dx, I just have to divide this on both sides. So in another words, we can get dx equal to 3u squared du on the top over secant square x, which is the same as u to the 6 and then plus 1, right, in the u world. And now we can just take everything, right, all this right here, and change that from the x world to the u world. Now we will have the integral. This right here is a u, so let's just put that down. And then we multiply by dx, which is this, right? So we have 3u squared over u to the 6 power plus 1, and then we can put the du on the side like that. And u times u squared is u to the 3rd power, and I will just write this down right here. I'm not going to put the 3 to the front. I will just write this down as the integral of 3u to the 3rd power over u to the 6th power plus 1 du. Okay, so this is the first step. And now, as you can see, we have a rational expression inside. To integrate this, you can try to do this by partial fraction. U to the 6th power plus 1, it's factorable, but you shouldn't do that. All right. Unfortunately, on the top, it's u to the 3rd power here, right? Because if this was u to the 2nd power, you know it's actually going to be much easier. So here is the problem, like how can we somehow simplify this integral a little bit? And the way that we're going to do it is, in fact, we are going to just do another substitution, so that we can reduce some power, right? And we are not going to do the things that we did with the integral of square root of x. I'm not going to divide everything by u to the 3rd power. You can try it, let me know. Because if we do that, we have to somehow complete the cubes. It's not that fun. And you can try it, let me know. But anyway, I will take another substitution. And this is the unusual part, I would say. And first off, let me just kind of draw a separate line right here. I'm going to use another letter, let's say t. And now here's a question. T should be what though? Should I let t equal to u to the 3rd power? Well, if we do that, you will see on the bottom, it's going to be t to the 2nd power plus 1. And if you differentiate this, you get dt, right? Let me just write down dt. It will be, we get dt right here. And we will get, this is equal to 3u squared du, right? Unfortunately, on the top, this is u to the 3rd power. And you know, you have to have another, you know, once you cancel the u to the 3rd power and the u squared, you will have another u. And if you want to solve for u in terms of t, you end up with the cube root of t, which is not great. I'm not going to do this, all right? I will try to avoid any radicals from here. But what else can we do though? How about let me try, instead of u to the 3rd power, let me do u to the 2nd power and hope for the best. dt will be 2u du, right? And now, let's see if this is going to do us any good. You know, this and that, well, one of the u's will be reduced out, and we will end up with u squared on top. And you see u squared is just t, so that's very nice, all right? So in fact, this is what we like to do. And before I do that, let me just clean things up for you guys a little bit. I think this is how I want to present this to you guys. This right here is going to be integral of 3, and then let me just write this down as u to the second power times u, which is the same as u to the third power, right? Same as that earlier. And then on the bottom, I'm going to write this as, instead of u to the sixth power, of course, that's write it down as u squared, and then to the third power, and then plus 1, all right? And for the du, let me just keep it as how it is for now. And let's see. Right here, I usually like to show my students to do the cancellation. So I would like to isolate the du. Let me divide 2u on both sides. In another way, we get du equal dt over 2u. And then this u and that u will cancel each other out nicely. All right, now, what do we have? This is going to be the integral, the 3 states, and the u squared is the t, so let me just put it down. And then this u stays. I'm just going to show you guys all the cancellations, so let me just write this down for you guys. Over u squared, which is t, so we have t, and then raised to the third power, and then plus 1. And then du, which is dt over 2u, so let me just put this down in black. I will say du is this, which is dt over 2u. And then you see that this and that cancel out. Everything is in the t world now, right? And to continue, I would now factor out the constant multiple, which is 3 over 2, okay? So let me just put that all the way to the front. We have this 3 over 2 in the front. And then this is the integral. On the top, we have what? We have this t, right? Over, this is t to the third power plus 1. And then this is dt. Okay, now let me pause this a little bit. Here, if you just look at the integral inside, right here we have rational expression. This right here, it's, I will say it's not easy, but it's easier to do partial fraction in comparison with this one, all right? And another thing that you may notice is that, in fact, we did 2 substitution. You could have done it to begin with, u equal to tangent to the 2/3 power to start with. Why? Because you see, the first was u equal to tangent x and then to the 1/3 power, right? And then here t is equal to u squared. So of course 1/3 and then to the second power is the same as 2/3 power. But as I said, if you start with this, it's not obvious at all from the original, right? So this is more fair. But yeah, anyway, this is something that you could have started off with, and you could save a few steps, but it's more confusing. And now, here's the deal. We will do partial fraction of this guy, and then we will integrate, all right? I will close this now, right here, and here is the time to do partial fraction. And let me just show you guys how to factor this real quick. This right here is the sum of 2 cubes, and you will get t plus 1, right? And then the formula says the second parenthesis is going to be the first term squared, the t squared, which is just t squared. And then you minus t times 1, right? So just minus t, and at the end you plus 1, right? This is the factoring for the sum of 2 cubes, right? So let me just put this down right here for you guys. And once again, we have to do partial fraction here, right? Partial fraction. And let's see how it goes. Let me just write down t over t plus 1 times t squared minus t plus 1, like this, right? And because the bottom we have 2 factors, so we know we can break this down into 2 little fractions. And the little fractions will be something over t plus 1, and then plus the other one is going to be t squared minus t plus 1. Okay, this right here is a linear, so I know on the top is just a constant term, which you will put on A. This is a quadratic. That means, well, sorry, this should be a constant, sorry. This is linear, so on the top is just a constant. And right here, this is quadratic. On the top should be a linear term, which is bt plus c, like that, all right? That's a setup. Okay, now, we can first do the cover up for the partial fraction. To get A, it's pretty easy. This is how we do it. just look at the denominator right here, which is t plus 1. You go to the original, you cover up the same denominator, and then you ask yourself, how can you make this factor equal to 0? Well, to make t plus 1 equal to 0, you have to let t equal to -1. So just cover this up, and then you plug in -1 into the rest of the t's. So you will see right away that on the top, we have -1 over, on the bottom, what do we have? -1 squared is going to be 1. -1 is going to be plus 1. In other words, 1 plus 1 and then plus 1. Altogether is just 3 on the bottom, right? So that's how you can do it with a cover-up method. And then what you can do next is you can just plug in numbers to solve for B and C, right? Once again, we used it. T is equal to -1 to get A. In order for us to plug in numbers to solve for B and C, we cannot plug in -1 anymore. We can plug in other numbers, all right? Okay, so now I would like to say just plug in some easy number. Let's say let t equal to 0. On the left-hand side, it's super easy because we just have 0, right? And on the right-hand side, this is just going to be -1/3 over 0 plus 1, which is just going to be -1/3, right? So I will just do everything in red right here, right? When t is 0, on the left-hand side we have 0, and this is equal to -1/3 over 0 plus 1, which is just 1. So this is what we have. When t is equal to 0, this is going to be 0. This right here is 0, 0, and then we have c over 1, so just plus c, right? Haha. This implies c is equal to, you add 1/3 on both sides, so c is equal to +1/3. How cool is that? So we know c is just +1/3. That's excellent. Now to find b, we used it -1, and likewise we used it t equal to 0. Let's pick 1. How's that? If t is equal to 1, on the left-hand side, we have 1 on the top over 1 plus 1, which is 2, times this is 1 square minus 1, which is 0, and then 0 plus 1 is just 1. So we have pretty much 2 times 1, which is just 1/2, right? And now, when t is equal to 1, plug into here. On the top, we have -1/3 over 1 plus 1, which is 2, like that, all right? And then we add it with b, I don't know, but b times t, t is 1, so we just have b right here. And then c is 1/3, so we put on +1/3 over plugging 1 into this, that. 1 squared is 1 minus 1, which is 0, plus 1 is just 1. And that's what we have, okay? And to solve this, well, just do whichever way that you would like. Multiply everything by 2 so you don't have to deal with fraction if you don't want to, right? Okay, so we have 1 equal to -1/3. And this is going to be plus, well, I multiply 2 right here, so it's going to be plus 2b plus 2/3. And now just do this a little bit quicker. This is -1/3 plus 2/3, which is going to be +1/3. Minus 1/3 on both sides, you get 2/3 is equal to 2b. In another word, divide both sides by 2, you get b is equal to 1/3, all right? All right, so b right here is +1/3. Just a lot of algebra here. This is the partial fraction part. And let me tell you, there are more algebra going to be coming. So yeah, should be okay with this. So here we go. This is going to be right here. We have 3/2, and then we have to integrate. The first fraction is -1/3, so let me just write that down. And in fact, notice that we have -1/3, 1/3, 1/3. Everything has a third, right? Let's factor the third out. So let me just put down the 1/3 in the front, and then I will have the integral sign. And the first term, now it's going to be just -1 over t plus 1, all right? So we have -1 over t plus 1. The 1/3 is in the front already. Next, we have this right here. Once again, the 1/3 is in the front already, so we just have t plus, likewise the 1/3 is in front, so t plus 1 on the top. So plus t plus 1 over this on the bottom, which is t squared minus t plus 1. And then we close that, we have the dt. Okay, this is pretty good, and especially the 3 and 3 cancel out, so that's what we have the 1/2 all the way in the front. Okay, this is easy, right? -1 over t plus 1, we can totally integrate that. But how in the world can we integrate this? T plus 1 over t squared minus t plus 1. Well, this right here, we cannot factor it anymore. This quadratic doesn't have any real valued roots, right? So what we have to do is we have to complete the square right here. So here is the completing the square part. So I will write it down here, right? Put this down in blue. So completing the square, CTS. Hopefully you guys don't mind. That's the abbreviation for that. This part, t squared minus, let me just indicate this is a 1t and then plus 1. To complete the square, this is what we do. Look at this number, it's technically -1, right? So what we do is we take 1/2 and then times -1, and then we square that. We have to find out what this number is. This right here, it's going to be -1/2 inside, square that, which is going to be 1/4, right? So this is 1/4 altogether. In other words, this is going to be t squared. I'm going to keep this right here as -t, and then I'm going to add 1/4 right here. These 3 terms, it's going to be a perfect square. And then I still have this plus 1, right? But of course, this is going to be different than the original because I added a 1/4. Therefore, I must subtract 1/4 right here. Okay, these first 3 terms are going to be a perfect square. And this is going to be t minus 1/2 squared. Well, you can factor it, but you see you can put down t and t. And -1/2 times -1/2 is positive 1/4. -1/2 combined with -1/2, we get -1. So this is the factoring for that, right? And then plus 1 minus 1/4 just equal to 3/4, right? Just do whichever way that you would like. So this is what we have for the completing the square part. So I'm going to replace this right here with the denominator here, okay? So as you can see, this part on the bottom now, we will have t minus 1/2 squared plus, and here's the deal. You see, this is going to be a sum of 2 squares. So instead of 3/4, let me write it down as parentheses, something square. I need to produce a 3. So that means on the top right here, I have to have a square root of 3. So let me put a square root of 3 right here over, originally I had a 4. Well, right here inside, I just have the 2. 2 squared is 4. Now that's what we have. Okay, so here we go. What do we have to do next? We have to do another substitution. And let me see, how can I possibly do this? I am going to just focus on this integral right here, if you guys don't mind. I will probably do it right here, all right? I will do this in blue as well. So to integrate this guy, let me just put it down here, all right? Just pick a note here. Integral of t plus 1 over, that for the denominator, t minus 1/2 squared plus square root of 3/2 squared, and then we have the dt right here, right? Now we have to do another substitution. I'm going to let w equal to this right here, right? Because you are going to use the inverse tangent, the arctangent. So I'm going to let w equal to the inside, which is t minus 1/2. And the good thing is that dw and dt are the same after you differentiate both sides. So that's nice. And look at, on the top I have t plus 1. So because w is equal to t minus 1/2, right here you can say that t is equal to w plus 1/2, right? And if you add 1, so t plus 1, which is of course w plus 1/2 plus 1, which is the same as w plus 1/2 plus 1, which is 3/2, like that, right? Okay, so now this right here is going to be integral. On the top, t plus 1 is the same as w plus 3/2, right? This was t plus 1. So let me just put down w plus 3/2 on the top like this. And then on the bottom we have this. This is just w, and we have that square. And let me just keep this how it is. Parentheses square root of 3 over 2 square. And then dt is the same as dw, so that's awesome, right? So now that's what we have. And what's next? Split the fractions. So I will just look at this as the first one as w over w squared plus, for the first one, well, let me just leave this for now. And then I'm going to close it, dw, right? And then for the second one, let me just say add it with, this is a constant multiple, let me put it in the front, 3 over 2. And then we have the integral, still the integral. Now I have the 1 on the top over w squared plus something, all right? And then I'll have the dw. What's the difference between the first and the second integral? The first one has a w on the top, so you know on the bottom, because it's w squared, we can just do another substitution, right? And you know it's going to work out nicely, and the answer for this is going to be ln of something. So I'm going to keep this as a number, right? Not a something squared. Square root of 3 over 2 squared, I'm going to write it down as 3 over 4, like that. But for this one, you know this 1 over w squared, I have to use the arctangent formula for the integration for that, right? So I'm going to write this down as square root of 3 over 2 squared, right? Okay. This right here, I call this to be the substitution in your head because I don't know how many substitutions I have done already. Just do another one if you prefer. That, I don't know, y or like z or whatsoever equal to the bottom, right? W squared plus 3 over 4. But anyway, you see the derivative on the top, the derivative on the bottom is just 2w. On the top we have w, right? So we can put 2 and then just divide by 1/2, right? Just divide by 2, so just 1/2. But anyway, you are going to end up with 1/2 and then ln inside on the bottom here, right? The inside here is going to be this on the bottom, which is w squared plus 3 over 4. And the deal is that this is a square plus this is just a number, right? Everything is positive, so we just need a parentheses. I do not need the absolute value, all right? So this is pretty much done for that. And now what's this? Let me write down 3 over 2. We have to use the formula to integrate 1 over something squared. That's a function, right? That's a variable, plus another number square, right? So the formula says we have to do 1 over, this is a, and a is square root of 3 over 2. So do the reciprocal of that. Therefore, we will have 2 over square root of 3. This is the 1 over a part, all right? And we will have the inverse tangent. And the inside is going to be whichever the variable that we use, which is w, over the a value, which is, I have to put down square root of 3 over 2, right? But you know the 2 will be come out here, so it's 2 over square root of 3, like that. Similar to this idea, right? So this part right here is pretty much it for that integral, all right? And that's pretty much it. And I just have to take this back to the t world, which I will right here for you guys. This is 1/2 ln parentheses, and check this out. W is what? W is t minus 1/2, right? So look at when you have, let me just put this down right here, I'll say, w squared is the same as t minus 1/2 squared, right? And then if you add that with 3 over 4, it's pretty much this, right? Once again, w is t minus 1/2, and then you square that, and then you add it with 3 over 4, which is the same as that, right? So let me just put this right here for the inside. Once again, this right here is just this, which is the same as that. So for all that, it's going to be t squared minus t plus 1, okay? And then, check this out. 2 and 2 cancel. 3 over square root of 3 is just a square root of 3, all right? So this is plus square root of 3. And then we will have inverse tangent. And then we have the 2 over square root of 3. And w is what? W is t minus 1/2. So let me write it down this way. We have a 2 over square root of 3 right here. And the w is t minus 1/2, right? So let me just put it down like that, if you guys don't mind. And of course, you can distribute whatsoever, but maybe we can do that later. And of course, let's not put down plus c because this is not the whole question. This one right here is. And then now we are pretty much ready to go, kind of. And let's see what do we have. There's not really enough space for us to finish all that. We'll try. First of all, we have 1/2 in the front. So let me just write this down. We have the 1/2. And now let's integrate. Integrate -1 over t plus 1. We know it's going to be ln, right? So let me open parentheses. So we have -1, and then this is going to be ln, and then we have the t plus 1, right? So, and then I don't know if it's going to be positive or negative, so I'm going to just use the absolute value for now. So absolute value, t plus 1, right? Wrong color right here. T plus 1. Okay, t plus 1. I'm worried if I have enough space or not. That's why. All right, so this is the first one. And the result of the integral right here is all this. So I'm just going to write it down. So we add it with 1/2. There's no way for me to finish the whole thing. So take a look right here, right? I'm going to just erase this part right here real quick. So we did all the hard work already, all right? Whew, I feel much better. Anyway, 1/2 ln is just a parentheses, t squared minus t plus 1, and then we have the plus square root of 3, and then the inverse tangent, and then we have the 2 over square root of 3, and perhaps if you guys prefer, let's just distribute. Why not? We have t over square root of 3 right here. We have this, right? 2t over square root of 3. And then this times that, you know the 1/2 and the 2 cancel also. We have minus 1 over square root of 3, like that, yeah? Okay, so this times that is that, and so far so good. All right, so that's what we have. We're done actually, right? Well, here are a few things that we have to do. We have to distribute the 1/2 into the parentheses, and then we have to get back to the u world, and then we have to go back to the x world, right? But let's take a look. We know t is equal to u squared, and u is what? U is the same as saying the cube root of tangent x, which is the same as saying tangent x to the 1/3 power. And let me write it down as the 1/3 right here, right? Wolfgang alpha used this as well. So this means tangent to the 1/3 power x, which is the same as the cube root of x, right? Cube root of tangent x. And because t is equal to u squared, if you square, you know t is equal to tangent to the 2/3 power x, right? So this is the little thing I'm going to use. So that way we can finish that, right? Now, distribute. So we have 1/2 times that. So we have -1/2 ln. T is that. So let me just put down tangent to the 2/3 x, right? This is the t. And then I will put down plus 1. And now here's the deal. You know this is something to the second power, so it's positive, right? This is a square, and then plus 1 is of course positive. So the inside is always positive, so I can put a parenthesis around it, right? And now I have to do 1/2 times 1/2. Therefore, that's going to be 1/4. And then this is going to be ln parentheses. By the way, inside here it's always positive as well, right? T squared, well, we have to square both sides. T is equal to tangent to the 2/3 power. T squared is going to be tangent to the 4/3 power, right? So for this term, it's going to be tangent to the 4/3 power x. And then minus, right? T is that, which is tangent to the 2/3 power x. And then we add 1 to it, all right? Well, we're almost done, oh my God. And then we take this times that. 1/2 times square root of 3. So let me put down plus square root of 3 on the top over 2. And then this is the inverse tangent. All right? Open the parentheses. Because they have the same denominator, let me just put down the square root of 3 on the bottom like this. And here we have the 2, so let me put down the 2. And then this t, which is the same as that, so I'll put down tangent to the 2/3 x, right? And then we have the minus 1 after that. Oh my god, this right here is the answer to the integral of the cube root of tangent x. We are all done. We put plus c. This is so satisfying, right? Whew. And please do not ask me to check the answer by differentiation, all right? Please do not ask me to check the answer by differentiation. I can challenge you guys. Maybe some of you guys can do it with a video. Then that would be great. But anyway, hopefully you guys like this. And maybe I'll do another video about like how to integrate this kind of thing separately. But hopefully you guys like this. And subscribe. That would be wonderful. Thank you. And that's it.